Okay, in this video we're going to talk about some systems of linear equations. Okay, we're going to solve them in 3 different ways: by graphing, by substitution, and then by elimination. Now when we have 2 lines and they intersect, an x and a y represents the solution. Okay, so if we've got one solution, that means I have 2 lines and they're going to intersect with one another. And then that place where they intersect, that's going to be my solution. We also have 2 special cases, though. We have 0 solutions, or we have infinitely many solutions. These are also options for me. To have 0 solutions, if I had 2 lines, well, they would have to not intersect, and that means that they would have to be parallel lines. So this is an option. They won't intersect. There won't be any solution. I can also occasionally have something that's called infinitely many solutions, which means that I actually have 2 of the same line, one graphed right on top of the other. Okay, same line. Okay, so solve by graphing, really nice and straightforward. Just graph both lines, and then wherever they intersect, that's going to be my solution. So I'm going to start by doing example B down here. So I have x plus y is equal to 2, and then 2y minus x is equal to 10. To solve these, I need to graph them, and to graph them, I'm going to need to put them into slope-intercept form. So I'm going to take my first line, x plus y is equal to 2. So x plus y equals 2. And to put it into slope-intercept form, I'm just going to subtract x on both sides. So we're going to have y equals negative x plus 2. So now I have my line, and I know that it's got a slope of negative 1 and a y-intercept of positive 2. So I can go ahead and graph that on these set of axes here. So here's my y-intercept of positive 2, and then a slope of negative 1 means I'm going to be coming down this way. And I can go back in the other direction. So this is my line, and I can draw a straight line right through these points. And here's my line. Okay. When I'm graphing more than one line on the same set of axes, I do want to make sure that I label them as well. This is kind of important so that we can tell what we're seeing here. So I'm just going to label this with the equation x plus y equals 2. For my second line, we'll also remember to put arrows on the ends because lines do extend infinitely in both directions. All right, second line, 2y minus x is equal to 10. Again, I'm going to put it into slope-intercept form, so add x to both sides. 2y equals x plus 10, and then divide everything by 2. So I've got y equals, it's going to be 1/2 x plus 10 divided by 2 is 5. So slope of 1/2, y-intercept of 5. So 5 on the y-axis. Slope of 1/2 means up 1 over 2, up 1 over 2. And I can go back in the other direction as well. And then just graph a line straight through these points. Okay, that's pretty good. Arrows on the ends, and equation 2y minus x equals 10. Okay. So finally, my solution, again, is the place where they intersect. So I see right here, and I can just read that right off of the graph. So my point of intersection is at -2, 4. Okay. Next method we can talk about is solving by substitution. Now when we solve by substitution, first thing I want to do is solve one equation for one variable. Now sometimes this is done for you already. For example, in this first problem, I see that the first equation is solved for x already. Okay. If it wasn't, then you'd have to take one equation, doesn't matter which, and solve for one variable. Again, doesn't matter which. What we're going to do with this is plug that into the other equation. So I'm going to take this expression for x and plug it in here. So I'm going to have 2 times 3 minus 2y. And then the rest of the equation plus 4y equals 6. And I can solve this equation, in this case for y. So distributing the 2, it's going to give me 6 minus 4y plus 4y equals 6. So we solve this for y, and then whatever we do, we plug back in to get the other variable. But in this particular case, what you can see is that my y's in this equation are actually going to cancel, and I have 6 is equal to 6. So this is a case that you want to be careful of. Whenever the variable actually drops out of an equation, okay, this is going to be one of those special cases, either 0 solutions or no solution. Because this is a true statement, I know that this is infinitely many solutions. Okay. So again, if your variable happens to drop out of the equation, okay, you're either going to get a true equation or a false equation. If it's true, infinitely many. If it's false, that would be no solutions. Okay. But again, very often it's going to be that you'll get one solution for y, and then you would plug that back in to get a value for x. Third method is elimination. Okay, to solve an equation by elimination, what I want to do first is multiply one or more of the equations, one or both, to get one variable so that it has the same coefficient in both equations but opposite signs. And again, doesn't matter which variable you pick as long as you've got same coefficient, opposite signs. So I want to start by doing example B here. And if I want to get one variable the same coefficients, opposite side, I can choose, let's see, maybe I'll choose this first equation and I'll multiply it by 3, say. Okay. So that's going to give me 6x minus 3y is equal to negative 21. The other equation I'm going to keep the way it is. 4x plus 3y is equal to 16. And we'll solve this equation. Next thing I want to do is add to eliminate, so I'm going to add going down. So 6x plus 4x is 10x. These cancel out. And negative 21 plus 16 is going to give me negative 5. Then divide by 10. And I get x is equal to negative 1/2. So there's my value for x. Okay. The thing I want to be careful of is that x is not the whole story. I need a y value as well. So I do want to make sure that I go back and plug in and solve for the other variable as well. So I'm going to take this negative 1/2 and plug it into one of the original equations. And again, it doesn't matter which, as long as I get a value. So let's plug this back into the first original equation. So 2 times my x value minus y is going to be equal to negative 7. 2 times negative 1/2 is negative 1. Minus y equals negative 7. Add 1 to both sides. So negative 1 equals negative 6. And then divide by negative 1. So y is equal to positive 6. Okay? So do make sure that you have a solution for x and y both. Finally, doing word problems. Okay. Really, I can use any method generally to solve these, and I'll show you one example of each. The key thing that we want to keep in mind is that we definitely always want to define our variables. Okay. And if you're not sure how to do this, a good place to start is to look for the question. So, for example, in this first problem, the question is how many cheese pizzas and how many pepperoni pizzas? Well, this tells me exactly what it is that I need to define. So I need two variables. One's going to be the number of cheese pizzas, and one's going to be the number of pepperoni. Oops. That should probably be an equal sign. Okay, so let's see. The cheese pizzas had 12 slices each, so 12 slices for each cheese pizza. Pepperoni pizzas had 8 slices each, so plus 8p. And there were 64 total slices eaten. I also know that I ate 6 pizzas in total, so cheese and pepperoni together is going to be 6. And I can solve this system of equations. Now I can do that really in any way I like. Let's say I'm going to solve this particular one by substitution. So if I solve this by substitution, I can solve, let's say, the second equation for c. So that would require me to subtract p on both sides, and so I'd have c is equal to 6 minus p. Then I can take this value for c and plug it back into this equation here. So we'd have 12 times 6 minus p plus 8p is equal to 64, and this will let me solve for p. So distribute the 12, 72 minus 12p plus 8p equals 64. Subtract 72 on both sides. Okay, and collect on the left, so I've got negative 4p is equal to 64 minus 72, which is negative 8. And when we divide by negative 4, we get p equals 2. So 2 pepperoni pizzas. Sorry, it's a little messy, but it says pepperoni pizzas. Yeah, there's no fixing that. That's not the end, though. I also want to know how many cheese pizzas, so I'm going to have to plug that back in. C is going to be 6 minus 2, so 4 cheese pizzas. Okay. And so there's solving word problems using substitution. Okay. We could also solve a word problem using elimination, and this is, I'll give that example in the second example here. So it is full of spiders and ants. Okay, and I want to know how many ants and how many spiders. So there's my question. Here's my defining variables. Spiders and ants. Okay. Now, I've got, let's see, spiders have 8 legs each, so 8 legs times the number of spiders, plus ants have 6 legs each, so 6 times the number of ants is going to give me the total legs, which is 156. And there are 22 total bugs. Ugh. And so S plus A is going to give me 22. Okay. I solved the last one by substitution, so I'll solve this one by elimination just to give you an example. So let's take this second equation and let's multiply it by, say, negative 6. So we'll get rid of the a's. So my first equation stays the way it is. 8s plus 6a is equal to 156. My second equation multiplying in the negative 6, so negative 6s minus 6a is equal to 22 times negative 6, which is negative 132. Oopsie. And now I can add going down, so my a's are going to cancel. This is going to give me 8 minus 6 is 2s is equal to is 24. Divide by 2, so s gives me 12 spiders. Again, plug back in to get the number of ants. So 12 spiders plus the number of ants is going to be 22. So if I subtract 12, then A has got to be 10 ants. So I did skip some of the problems throughout this lesson. I'm going to ask you to go back and do all of those problems, and we'll go over the answers in class tomorrow.